Hi everyone. In today's video, I will take up a new question in the topic of trim. This is type A from Captain Subramaniam's book, Captain Subramaniam's Ship Stability Series Part 2. And this question is from exercise 22, question number 20. So without much ado, let's get started. The question is, there is a ship that leaves port drawing 9 meters forward and 9.8 meters aft. This is the initial, or rather, the initial drafts we start off with. So it's leaving port with 9 meters and 9.8 meters forward and aft. The length between perpendicular is 170 meters, MCTC 160, TPC 24, and the HF, which is the longitudinal distance between the center of flotation and the midship, is 1 meters forward. This means the center of flotation is 1 meter forward of the midship. On passage, the vessel consumes the following. So you have 520 tons heavy fuel oil from number 2 DB tank. The HG is provided. HG is the longitudinal distance between the midship and the center of gravity of the tank itself. This is going to be important to determine the longitudinal distance between the center of gravity of the tank and the center of flotation. That is what is important for us. Then 200 tons of heavy fuel oil from number 8. Again, HG is given. I'll draw the diagram and explain to you how to use this information. And then 300 tons of fresh water from number 3 DB tank, and HG of which is given again. What you have to determine is how much fresh water must be transferred between the peak tanks. So that will be aft peak to fore peak or fore peak to aft peak, you don't know. They are located 150 meters apart, and this is to bring the trim to 0.3 meters by stern. You also have to state the final drafts forward and aft. Alright, so once you have read the question carefully, make sure that you draw the diagram. So again, I will draw the diagram for you. So make sure that visually you can understand what is going on here. Alright, so this is somewhat the situation is. And my diagrams, I always laugh at my diagrams because they are a bit ugly. But anyhow, this is the forward draft that we start off with, which is 9 meters, and this is 9.8. I've kind of exaggerated a little bit to make it easy for us to understand. And then we draw the midship somewhere here. This is the midship, you can call it H. HF, so F is here somewhere here, 1 meters forward of the midship, so we call HF 1 meter forward. The total length of the vessel is 170 meters. So that means each midship, or from aft perpendicular to midship, is 85 meters, half of LBP, and from midship to forward perpendicular is 85 meters again. So midship is half of the length between perpendicular, as you guys already know. MCTC and is 160, TPC is 24. I'll summarize that information here again. And how have we consumed? Let's understand how we have consumed. So I will use a different pen. So we have consumed, let's say, 520 tons. So I'll write minus 520. The HG is given. That means from midship to center of gravity of the tank, the distance is given as 50 meters. But the distance we are interested in is from F to G this here, which you can see here in this case is 50 minus 1, 49 meters. Alright, from F to G1. This is the distance we are interested in. Similarly, we have consumed 300 tons. Or let's do the 200 tons from number 8 DB tank. So let's say I'm just drawing it at random. I don't know where the tanks are located, to be very honest. So this is G2, I'll call it G2, and minus 200 tons of fuel oil you have consumed from here. Again, H to G is given to us as 60 meters, but what we are interested in is G2 to F, which is 60 plus 1, 61 meters. This is the distance we are interested in, G2 to F. And similarly, we have consumed 300 tons somewhere here. Let's say 300 tons of fresh water, G3 I'll call it, minus 300 tons. and again the hg is given to us as hg3 is given to us 30 meters, but the distance we are interested in is from f to g3, which is 29 meters. Alright, so we are, to understand the trim questions, we are only interested in the distance between the center of flotation and the center of gravity of the tank. And that hg is given just to confuse you a little bit, also to give you some kind of a reference. Alright, so let's get started with the question. So your departure trim, let's call it the departure trim, is 9.8 meters minus 9 meters. So of course you will, this is the aft draft, this is the forward draft. So you had 0.08 meters by stern was your initial, or not your initial, but your departure trim when you departed port. And then your desired trim, let's call it your desired trim, after you have consumed the fuel oil and the fresh water, and you have transferred 150 tons of fresh water. So that will be 0.3 meters by stern. Again, this is given to you in the question. So remember, the question says that your desired trim is 0.3 meters by stern. That is what you desire it to be. So if I subtract one from the other, that means the change in trim I would like is 0.8 minus 0.3, which is 0.5 meters by stern. Sorry guys, it will not be by stern, but it will be by head, because initially if your vessel was 0.8 meters by stern, and then it goes up by 0.3 meters. So remember, I'll just show it to you by a drawing, that if your vessel was initially 0.8 meters by stern, so this is 9.8 and this is 9 meters, let's say, right? So your vessel was 0.8 meters by stern, but then after all the loading and shifting operations, your vessel's desired trim is nothing but 0.3 meters. So this difference between the forward and aft draft becomes much lesser. So I should maybe draw it like this, something like that. So that means if this is now, the vessel is trimmed by stern, don't get me wrong, the vessel is still trimmed by stern, but it is only 0.3 meters by stern instead of 0.8 meters. So after all the loading operations and everything, the vessel's stern must have lifted up by 0.5 meters. So although the vessel is still trimmed by stern, it has lifted up, because of which the vessel's stern or stern trim is only 0.3 meters by stern. That is the desired trim. So therefore, what is 0.5 meters by head is change in the trim required, or rather change in the trim that will be achieved after the loading operations or shifting operations is finished. All right, so that means we need to have more loading in the, or more moments created by loading or shifting or discharging operations by head than by stern, because that is what the desired trim, we would get the desired trim like that. So let's see what discharging operations have been carried out and what loading operations have been carried out. So we can see that all the three discharging operations have been carried out, but there is one shifting operation that will be carried out from aft peak to forepeak, or forepeak to aft peak, depending on what is it that will require. So because we require more trim by head, we will see what the resultant trimming moment is being created by these discharging operations. Not discharging, these are actually stores being consumed. So these are HFO being consumed, fuel oil being consumed. So don't let me call it discharging. I call it discharging because it's weight being taken off the vessel because of the consumption. All right, so let's see what we have to do now. Let's summarize this here. So let's say we call it consumption, or you can call it very similar to discharging, right? Similar to discharging, because weight is being off the vessel, weight is getting off the vessel. So we'll call it minus 520 tons first, minus 200 tons, and minus 300 tons. All right, distance from center of flotation, we have already determined the distance from center of flotation. So G1, that is 520 tons, is 49 meters F to G1. Remember, we are only interested in the distances from center of rotation to center of gravity of the tank space or cargo space, from where weight is being loaded, discharged or shifted. We are not interested in HG. That is only given to us to give us an indication of where the center of rotation is. Similarly, G2, and the distance from center of rotation to G2 is 60 plus 1, 61 meters. And from center of flotation to G3, from where 300 tons is being consumed, is 30 minus 1, 29 meters. I have explained this to you earlier, so I think you get it. Right? So we have to remember distance from center of rotation. Alright, so from center of rotation to center of gravity of the tank, that is the distance we are interested in. So in the first case it was 49, then 61, and then 29. Now when 520 tons of fuel oil is being consumed in G1, it is being consumed from the forward part of the vessel. That means you can say some kind of a discharging taking place from the forward part of the vessel. So where will the vessel trim by? So if you take off the weight from the forward part, vessel will trim by stern. So therefore what we have to do is create two columns. So we call it trimming moments, and you have to create two columns by head and by stern. Alright, so if I am taking out 520 tons from forward part, it's going to trim by stern. So 520 multiplied by 49 will give you 25480 trimming moment by stern. Now 200 tons of HFO is being consumed from G2, that is being consumed from the aft part. So if the weight is being consumed from aft part, vessel will trim by head, because you are discharging something from the aft part. So aft will become lighter, so vessel will trim by head. So in the second case, you will get a moment by head, 12,200. And in the third case again, 300 tons of fresh water is being consumed from the forward part of the vessel. That means a weight is being lifted off the forward part becomes lighter, vessel will trim again by stern. So in the third case, 300 tons of multiplied by 29 is 8,700. So if I add the stern moment together, I am getting 34,180, whereas the head moment is only 12,200. And we have determined earlier that we need more of the head trim. Because I need the vessel to trim by head by 0.5 meters, because the vessel is currently trimmed 0.8 meters by stern. I need the stern to come out by 0.5 meters so that the vessel can go down by 0.5 meters, so the resultant trim or the desired trim of 0.3 meters by stern can be achieved. So therefore for that I need a moment by head, right? So therefore what I'll do is, if I have to transfer 150 tons will be transferred from the aft peak to forward. That will be the direction in which it will be transferred, because if I transfer the weight forward part becomes heavier, vessel will go down by head, so the stern will come out of the water, so that way I can get a little bit moment by head. So 150 multiplied, 150 is not the 150 is the distance. I don't even know how much weight I have to transfer, so x by 150, which gives me moment by head by 150x. Alright, so net moment. So let's calculate the net moment now. So trim moment by head is 150x plus 12,200 is the trim by head, and trim by stern, or not trim by stern, sorry, trimming moment by head is 150x plus 12,200, and trimming moment by stern is 34,180. Alright, now because I want the head trim to be more, I will assume this number is more. 150x plus 12,200 is more minus 34,180. This is the net trimming moment, and the head trim, the trimming moment by head has to be more. So therefore I have put the 150x plus 12,200 as the bigger number and minus 34,180. So this becomes 150x minus 21,980. this is the trimming moment. But trimming moment can also be calculated by this formula here, where change in the trim required equals trimming moment by MCTC. So change in the trim required is 0.5 meters, or you can say 50 centimeters in this case. 0.5 multiplied by 100 is 50. So 0.5 meters has to be converted to 50 centimeters. This is change in the trim required, TC. Right? Why? Because moment to change trim by 1 centimeter, MCTC is in, it works only for centimeters. So TC, which is equal to 50, equals trimming moment that I don't know, divided by MCTC, which is 160 given to us. So trimming moment will also be equal to 160 times 50, which is equal to 8,000. So trimming moment equals 8,000, and trimming moment also equals to this here. So we've got two equations from trimming moment, which we can then equate to one another. So what we can say is 150x minus 21,980 from equation 1 equals 8,000 from equation 2. Therefore x equals, you can say, is 21,000, sorry, just let me calculate this. 21,980 plus 8,000 is 150x equals 29,980, or x equals 29,980 divided by 150 is equal to 199.9 tons. 199.9 tons, or I'll just round it off to 200 tons. So you will transfer 200 tons of cargo from aft peak tank to forward peak tank. I have solved one part of the question, but now I have to make sure that I also calculate the final drafts to ensure that my desired trim of 0.3 meters by stern is achieved. Right? So how do I do that? So I just go back and I calculate change in the trim after the loading operation is completed. So change in the trim after loading operation is completed will be TC equals net trimming moment. So net trimming moment was 150 multiplied by x, which this is 200, plus 12,200. This is the net trimming moment, right? Remember, this is the trimming moment by head minus trimming moment by stern. This is 34,180 divided by MCTC is 160. So this is nothing but 8020 divided by 160, which is equal to 50.125. This 50.125 is actually centimeters, because MCTC is working only for moment to change trim by 1 centimeter. So we can convert this into meters, or you can leave it for now and use this to find the value of change in the trim aft and multiply by change in the trim forward. So change in the trim aft formula is from aft perpendicular to center of rotation, AF multiplied by change in the trim divided by LBP. So in this case AF is 86 meters. Why is AF 86 meters? Because from aft perpendicular to midship I can see is 85 meters, and center of rotation is 1 meter forward of the midship. So from aft perpendicular to midship is 85, and from midship to center of rotation is 1 meter. So from aft perpendicular to midship will be 85 plus 1, 86 meters. 85 plus 1, 86 meters is the distance AF. Alright. So we come back here, 86 meters. Change in the trim required is overall change is 150.125 is what the overall change in the trim achieved after the shifting operation was completed, and then divided by LBP, 170 meters is given to us. So TA equals 25.36, and this is again centimeters. TF is nothing but TC minus TA. So 50.125 minus 25.36, which is equal to 24.76 centimeters. Right. There's also another thing that you have to calculate. Oh sorry, my next video for my next material is coming up, so I better erase this, otherwise you guys will get confused. I need more space to write. I thought I'll be done with the space provided, but yes, I have to delete this. I must delete all this, so please bear with me. I must delete all this to create space for this question here. You will see the video for this question as well, so don't worry about that. So you can see I have calculated TA and TF, but you see there is a lot of weights being consumed from the vessel, right? So you are consuming 520 tons of HFO, then again 200 tons of HFO, then 300 tons of fresh water. So all this weight being consumed is making the ship overall lighter as well. So you have to calculate that effect as well. There will be an overall effect on the vessel because of the weight that is being consumed. So the total weight being consumed, so what we have to do is calculate mean rise of the vessel. So mean rise, because these weights are being consumed. If the weights were being added, you would calculate mean sinkage. So 520 tons plus 200 plus 300 is the weight discharge divided by TPC, which is 24, gives you 42.5 centimeters. This is the overall rise of the vessel because of the consumption of these stores. All right, so initial drafts, see, I'm now getting excited. Initial drafts was 9 meters and 9.8 meters. This is forward and this is aft, right? Then because of the consumptions of the store, there was a mean rise of the vessel, overall rise of the vessel, which affects both forward and aft part. By how much? 0.425. So this 42.5 centimeters has to be converted to meters by dividing by 100, which will make it 0.425 meters. Why do we convert it to meters again? Because now we are talking about drafts. We talk about drafts in meters, so we need everything in meters. So 0.425, and this gives us drafts after rise is 8.575 and 9.375, and then we have TF or TF and TA. So remember, TF is 24.76, so this can be converted to meters as well, 0.2476 meters, and this 25.36 can be divided by 100. So you just divide by 100 to convert centimeters into meters. This becomes 0.2536 meters. So remember, forward draft is going to be added because the forward moment was more. Remember, because the forward moment was more, you will add the TF, and the aft one you will subtract because the stern moment was lesser, 0.2536, which will give me a final draft of 8.8226 and 9.1214. So 9.12 and 8.82 will give me a stern trim of 0.30 meters by stern. So I have done a cross check and I have achieved my desired trim by stern as stated out in the question to begin with. So this is like a cross check that you do to make sure that what you have calculated is correct. So the amount of weight you have transferred from aft peak tank to forward peak tank will lead to the desired trim by stern. So guys, watch this video carefully, watch it slowly, draw drawings, draw diagrams to get an understanding of what is it that we set out to achieve. Drawings become very important in such type of questions because otherwise you will not get clarity of thought, you will not be able to visualize what's going on. So you can see I keep drawing figures here to get an idea of the distances. It's a bit of a long question. I know that some of you may have got a bit confused. If you did, please put in the comment section. I'll try my best to answer it. I do get lots of questions during the day, so I try my best to answer it as best as I can. I apologize if I have not answered your question in the past. Thank you for watching today's video, and I'll see you soon. Bye for now.